Hello and welcome to a new video series. This video series is going to be a little bit different than the video series which I have recorded in the past and which I will continue to be recording on this channel, which cover the main chemical engineering courses that I'm taking. However, this playlist will specifically cover the Physics 2 course which I am taking this semester. Each chapter I'm going to create approximately 1 to 2 videos depending on the content in the chapter. And in these videos, I will do sort of an at-home physics experiment where I will take, everyday objects that we have at home and perform an experiment that relates to that chapter and explain the physics phenomena, if you will, behind that experiment. So for this first video, in the first chapter that we are taking a look at in this course this semester, it is titled Electric Field. So it involves the electric field, something that is very hard to see, or we can't really see with our bare eyes. But if we perform certain experiments, we can get sort of a visual of what is going on in everyday space. So this experiment I'm going to perform here, I'm going to take this balloon here, and this balloon is negatively charged here. There's no charge on this balloon. Now, what I'm going to do is I'm going to perform this experiment the first time without explaining anything. And the second time, I'm going to run through the experiment again, and I'm going to explain everything as I am going. And lastly, in the last part of this video, I'm actually going to transition to my whiteboard here, where I write down just some basic vocabulary terms that describes this experiment. And I'm also going to draw sort of a visual to help us understand what is actually going on. So first, I'm going to go ahead and rub this balloon all over my hair. Okay. Now normally, this balloon, if I put it onto this wall, would just fall down. And since I am rubbing it on my hair, you'll see what happens. It's falling a little bit. It's a little bit humid in here, so it might not work as well, but you'll see it's clinging to this wall. It has an attraction to this wall. So I'm going to go ahead and do this again and explain every step of the way what I'm doing. So first, this balloon is charged now since I have rubbed it on my hair, but let's say I'm performing this experiment for the first time. So we have a neutral object here, and what I'm going to do is I'm going to charge it by conduction. Now, charging by conduction means actually charging it physically by touching it. So I'm going to take this balloon and charge it by rubbing it on my hair, where it will give this balloon, which is neutral, now a charge. Now what I'm going to do is I'm going to put this charged balloon up towards this wall, which is neutral, and you'll see that it sticks. Now you might say, well, how does this stick? Well, there's something called induction. Now we know that conduction is actually charging an object by physically touching it, such as rubbing this balloon on my hair. Now, charging something by induction is a little bit different. You do not have to touch the object that you are trying to charge. So we have this charged balloon here, and again, I said this wall is completely neutral. There's no charge on this wall. Now, when I bring this charged balloon, we don't know the exact charge on it. I don't have a device to say whether it's charged negatively or positively, but let's just say that this balloon is charged negatively. Now, when I bring this balloon to this neutral wall, and I bring it closer and closer, you'll see that it sticks. Well, why does it stick? What happens here with this neutral wall is you can essentially think of it as a shift of the charges within the wall. So the positively charged, the protons here, the positively charged particles in the wall, move out towards the surface. Since this here is negative, there wants to be an attraction between the wall and the balloon. If you didn't know, opposite charges attract each other. So positive attracts the negative. So what happens, again, is the positive comes out towards the surface, and the negative particles in this wall will actually shift away, causing sort of a separation in the charge balance, if you will, of the wall. So now what I'm going to do, now that we've seen this experiment with a charged balloon and we've seen the charge separation in a neutrally, I wouldn't say charged, but a neutral wall here, I'm going to shift to my whiteboard here and just write down some basic definitions so that we have an understanding of what's going on going forward. And I'll also give a visual on a microscopic level of what's going on here as well. So here I have shown the two vocabulary terms we talked about. Induction, which we saw when the balloon came to the wall, which is charging without physically touching an object. So when this balloon got closer and closer to the wall, there was a shift in the neutral wall for the positive charge to come towards the surface. Now conduction, which we saw when I rubbed the balloon physically on my hair, was a physical charge of the balloon. So that's charging by physically touching an object. These aren't exactly scientifically worded definitions, but it's the best way to think about them, and it's how I have learned this concept personally. Now here I have just a visual of what's going on with this electric field between the balloon and the wall here. So if we have the balloon here, again, we said that we'll take the balloon as charged negatively. So we have much more a negative charge here than our positive charge. Maybe not much more, but it's charged negatively. You get the point. Now here we have our wall, which again is beginning out neutral. Neither the positive nor the negative charges shift towards one side of the atom here. Now what happens here when we bring this balloon closer and closer to the wall, this negative charge that is leading with the balloon, since it is negatively charged, this actually causes the wall's protons, so the positive charges here in the wall, to shift out toward the negative charge. That's how there is an attraction between the wall and the balloon, and that's why the balloon essentially sticks to the wall, because the negative charge for the balloon is highly attracted to the positive charge of the wall. So that's it, sort of a simple explanation, but that gives us the basic idea for electric field, and it's a good experiment to perform to actually visualize what is going on when we charge these objects. So that will do it for this video. Thank you.